Hello everyone. So in this video, I'm going to show you step-by-step way to self-study for your exams. And this topic that I'm taking, the subject that I'm taking today is Cambridge Science. So when it comes to science, especially doing it, preparing for it the Cambridge way, we have to be quite mindful about the process. So without wasting any of your time, I'm going to dive in and show you how exactly I am going to tell you to do this. So it's instruction based learning. Why I'm telling you it's instruction based right now, because I'm going to show you the steps that you have to follow. And the exploration part is all up to you. So how much ever you can dive in, dig in, search on internet. It's just it's like you can decide how much ever time you have during your preparation and take appropriate steps. So without wasting any further time, I want to show you how exactly I do. So here is a Cambridge Reader app, this one. And here I have downloaded all the ebooks, and this one is Cambridge Primary Science Learners Book 5. And the topic that I'm going to take today is seasons and adaptations of plants and animals. So firstly, I'm going to show you how I learn, considering if I am a student. So I'm going to firstly go through it. I'm not going to read it right now because I'm going to give you the key points, and then I'm going to tell you how to go about it. So this video is going to give you a conceptual clarity, and as and when I ask you to follow a certain step, you do it. For example, if I'm explaining right now, just listen, and when the turn comes where I ask you to read the entire chapter like a story, solve the exercises, then you'll have to do that accordingly. But for the moment, just be a good listener. So the first topic is the Earth's movement around the sun, and this is how exactly it is. We will be focusing a lot on the keywords like what is orbit, what is axis, and details like Earth is rotating on its axis and it is revolving around the sun in a fixed orbit. Now, the orbit is slightly elliptical in shape, and this movement happens anti-clockwise. And day and night is also caused because of a certain factor, which I'm going to take in the next page. Here, in this page, it's talking about the seasons, and we know there are 4 seasons, and exactly how seasons are formed. It's explained here. So basically, Earth is divided into 2 hemispheres, northern and southern hemisphere. And the equator divides it. And this is going to tell us how exactly we have winter season in a particular hemisphere and summer in the particular one, and vice versa. Also, there's something else that I want to bring to your notice is why days are longer in summer and nights are shorter, and vice versa. So all the explanations I'm going to give you in some time. So here, this diagram is very important, and do notice the tilt of Earth on its axis. Now, here it's the same explanation that they're talking about, and here they have taken a position of Earth in December and how it is influencing the season. I'm going to explain this in detail. So, once I do 6.1 with you, I'm going to go back to my notes and I'm going to take all these topics separately for explanation. So here you go. So this is exactly how I've done this. This is something that that I've used to explain my daughter. I'm gonna work on the same diagram again. I'm just going to change the color so that you will know that this is something that I'm doing it for you. So there's something that is known as day and night. What causes day and night? So rotation of Earth on its axis causes day and night. So the part that faces the sun is experiencing day, and the part that is away from the sun, it's experiencing night. Now, this is what we were talking about, that it's a fixed orbit, and here the axis is tilted, and this is the equator. And if we see, we have the southern hemisphere experiencing sunlight. So even if I have not mentioned anything, we can write that it's summer in southern hemisphere, because we can see that the rays are reaching more on the southern side. So it's going to be hot and warm, and that's why the people in southern hemisphere are going to experience summer. So also, it's very important that we know that the Earth's orbit around the sun, the revolution around the sun is in anti-clockwise direction. Now, there are two features of Earth which we need to understand. When we say that Earth is tilted on its axis, so what are the after effects of this? So in that case, we will say that the days are longer in the summer and shorter in the winter, and the Earth's rotation on its axis, it's causing day and night. And C, Earth's revolution around the sun in a fixed orbit is causing change of season. Revolution around the sun in fixed orbit is causing change of season. So these are the things that you have to know, and if you're preparing for exam, you have to be quite sure of all the facts. Now, orbit, you should know orbit in key points. It's an imaginary path taken by the Earth. It's slightly elliptical in shape. Axis is an imaginary tilted line which passes from North Pole to South Pole, on which the Earth rotates or spins. Now, something that I want to take in depth. So this is our Earth, all right, and this is the axis, and imagine this is an equator, and when I write NH, it's northern hemisphere. When I write SH, it is southern hemisphere. Now, without me telling you which season it is, let's see if you can answer it or not. Now, this is the sun ray, sun's ray. And if we see, and let's use red, southern hemisphere, more than half a quarter is receiving sun's ray. Since it is tilted, since it is tilted here, you can see even this part, the extra quarter is receiving sun's rays because the axis is tilted. So the extra part of southern hemisphere is receiving sunlight, and whereas if we compare this portion only, because we have to work in a straight line, right? This is where the lights are going to reach. So if we see in the northern hemisphere, less than a quarter is receiving sunlight. So we know that sun makes the temperature, the weather warm. It's very easy for us to say that here it's winter season, and here, since it's more than a quarter, southern hemisphere is experiencing summer season. All right. So the next part is that which part on Earth is experiencing complete daylight and complete darkness. So if I see this portion here, which is the South Pole, this is experiencing 100%, like 24 hours of daylight, because the Earth's spinning is happening over here. So whenever it spins, it's directly in contact with the sun's rays. So it's receiving light for full 24 hours. Whereas if we compare this portion, there's no light that can reach, no sun's light that can reach over here, this part. No sun, sunlight that can reach here. So this will experience 24 hours of darkness. So this is a very important concept. And that is why if I ask you something else, that why sun sets early if you are in London in winter season, whereas if you are in India, the sun sets early as compared to summer during the winter season. But comparatively, in India, the sun sets, say, around 6 p.m. But in London, it's completely dark by 3 p.m. Um, during the winter season. And why it is so? Because these cities are placed differently on the earth, right? So India is more of a tropical country. It's closer to the equator. So it's going to receive sunlight for a longer time, even in winter. Whereas London, it's more towards the North Pole. And that is why, when the earth is rotating on its axis to have that change of day and night, its rotation is causing less amount of sunlight to reach. And that is the reason by 3 p.m. the sun sets in London. So that's all that I wanted to talk about in this particular topic. Now we will move on to 6.2. You may pause right now and you can continue with the next chapter tomorrow. But I have to record the whole concept in one video. So I'm going to resume from here. So your homework would be that you, after watching all that I have explained, you should be reading 6.1 completely. And then you should be solving all the questions that's given over here. You can orally do that, or if you want to, you can write it down as well. So these are the questions that you have to solve. I'm sure after the explanation, you can easily answer these questions that's mentioned in activity 1 and activity 2. Now, moving on to seasonal changes. Now, this is sunrise, and we would see basically this chapter is talking about why sun sets differently at a different time during summer season and winter season. Why we have longer days in summer and shorter days in winter, which I have explained you even in the previous subheading, but I'm going to explain it to you again. This particular log sheet is very important, and I want you to infer from it. Now, how can we infer? What are the things that we can infer from it? Let me take a screenshot so that I can do the writing work with you and tell you exactly what to understand. Now, as you can see, and I will not be giving you any answers, and you have to tell me. Here, this is February and the length of the day, which means the time when you are receiving sun's light. All right, sun's ray is 13 hours. Now it's reducing. It's coming to say 13 hours and 42 minutes, 13 hours 40. On 7th of February, it's 13 hours 32 minutes, which means that daylight is decreasing, isn't it? From 13, it's coming down to 12 and so on. So when the daylight decreases, can you tell me which season are we going to enter? Yes, you are right. Right now, this particular country or hemisphere or city is experiencing summer because the days are longer as compared to this moment, which is 1 hour, less than the previous month. It is entering into winter season, but I will not say that it's completely winter season. If this is summer and this is winter, so it is in between. So it's going to be fall, that is autumn. So this is exactly how you should be inferring information from such data. Cambridge Science requires such deep analysis of any text or information that has been shared with you. We know this was summer. We know that the day is decreasing. We have not completely entered into winter. So this is particularly a fall or autumn. So that's what I wanted to talk about. Now let's see the next page. Now, it's very important to understand the adaptations of plants as well as animals. We know that in the presence of sun, um, plants um, have the leaf as green, and that is because they have a green substance which is known as chlorophyll. So chlorophyll in the leaves helps to produce the food for the tree, and the chlorophyll is generated in the presence of sun. But as the seasons are changing, so is the amount of sun that these trees, the sun's light that these trees will receive. So there has to be some changes in them. So what are the changes we're going to be understanding? So these plants are adapted to the seasons that when it is, say, spring, when it is summer, they'll have green leaves. And when it is closer to autumn, they're going to have orange or red leaf because now they're experiencing less amount of sunlight. And as soon as it is winter season, since the leaves have turned red and orange, they will wither, they've become weak, and the stalk is going to break, detach from the branch, and the leaves, the tree that you see becomes leafless over here. So based on the tree, you can tell which season it is, right? Green is because summer season, orange is autumn season, and winter season is when it's completely leafless. And during the cold winter months, the tree has no leaves at all and it is in the dormant state. Now, a question that you may ask, that leaves make food for the plant, right? And without leaves, the plant is going to die. The tree is going to die. Now, this is the adaptation that the tree has undergone, that, during winter season, when there's no leaf, they are going to go in a dormant state. All right. And very soon they're going to have new flowers, new buds, new leaves in spring season. And that's how they're going to survive. So depending upon which city we are, maybe if winter lasts for 3 months or 1 month or 2 months, the tree has been adapted to withstand that situation. So again, this is the end of, I think, yeah, there's animal adaptation also. So when it is winter season, these animals who stay in environment which experience complete, or I would say very cold climate, they undergo adaptation. So the animals can adapt in two ways: either they migrate or they hibernate. So migrate means they're going to fly, they're going to change their um, homes temporarily, they're going to move from a colder place to a warmer place. This is known as migration, which is again a part of the adaptation. And the next one is hibernation. So animals who don't have that much energy to travel, so to travel such long distances, they are going to hibernate. So small animals, or bulky animals, they hibernate. Like polar bears are bulky, they cannot travel thousands and thousands of miles and move to some other place. Instead, they prefer to hibernate. So they will find a cozy place, they're gonna eat a lot of food, because when they are hibernating, the extra fat that has been deposited on their body will definitely keep them warm and also provide energy, because they are not eating, they're sleeping, they're in a dormant state. So naturally the body is utilizing energy from the extra fat that has been stored in their body, and they will not die. So this is again an adaptation that they have done to survive in such adverse condition. So again, we have finished 6.2. So the homework for now is you stop, you pause the video, and you read the entire text carefully, underline difficult words, underline keywords, look up for it on internet, solve the questions orally or verbally, whichever form is convenient for you, and do refer to any worksheets that has been provided by school so as to test your understanding. I will always encourage you to have clarity in thought process, and I'm sure such explanation that I've given to you helps you. Now we are moving on to 6.3. 6.3 talks about plants and animals which are adapted to different environment. Now, before this, we were doing seasons, okay? Seasons are different to environments. Again, I would say that listen to me just like I am telling you a story. Consider me as a storyteller and stay all ears, be all ears and take all the information that I'm giving. Now, think about it, why this chapter has been included, right? Here they're talking about different environment, and before this we have done seasons. So what is the difference between environment and season should be the first question that should pop in your mind. That how does environment differ from seasons? Now, environment is the weather condition, um, or the quality of air, the quality of soil, the quality of the environment which is there throughout the year. Whereas seasons, it changes with each passing month. So in a particular environment, definitely they are going to experience different seasons. Okay, so here we are talking about, say, hot and dry environment, which is, say, a desert. But it doesn't mean that it's not going to experience winter season. Definitely it's going to get little colder comparatively to the amount of heat that it experiences in summer, but it's going to have that seasonal change also. Definitely countries or places or cities which is on the equator, they don't experience any seasonal change because throughout the year they are receiving the same amount of sunlight. And since the sunlight remains the same throughout the season, they are not going to have any change of season. All right. So throughout the year, that's what I meant to. Since since equator receives the same amount of sunlight throughout the year, there is no change of season. So here we are talking about how plants and animals have adapted to different environment. Here we talk about cactus, and cactus is grown in hot and dry environment. So what are the adaptations? So just in order to survive in a place where we have less water, how has this plant adapted? So definitely you have to do it in points. Point number one, instead of leaves, they have the thorns, as you can see here. They have thorns instead of leaves so that it's going to lose less water. Now they have waxy coating on the stem, which is a which will again cause less water to evaporate. Now they have fat stems to store water, and very important, they are going to have deep roots to find the water under the surface, since it's desert and they don't have access to water on top layer. So the roots are pretty long and deep. Now, next is we're considering an animal who stays in a hot and dry climate, right? So how has this particular animal adapted? Now they know that all that they're going to eat would be plants which would have more of thorns than leaves, right? And if they don't have thick lips, their lips are gonna bleed because it's going to prick. The thorns are going to prick. So they have thick leaf, thick, they have thick lips, so they can eat thorny desert plants. They have long eyelashes to keep the sand out of the eyes. They have humps so that they can survive without water for more than a week, etc. And then they have wide, tough feet so that they can walk easily on the sand. Smaller animals like rats and lizards also live in dry place, but then they turn out to be nocturnal there. So since days are warmer, what they do is they dig in burrows and they sleep during the daytime when it is warm, because these burrows are pretty cool. And then they come out only in the night when the outside temperature is cooler. So this is the adaptation they have done, that although we would not consider rats and lizards to be nocturnal, but if they are living in hot and dry climate, they turn out to be one. So this is the adaptation that it has done. Now, the second part is adaptations of plants and animals in wet environment. Again, if you read about the plants, they have weak roots, they have short roots. So the reason why they have weak stems is they get ample amount of support from the water, so they can stand erect inside the water, outside the water, with the help of water. And since they are already inside the water, underwater, they don't need a long root, so that's why they have short roots. They if we talk about the leaves are flat so that it can easily float on the water, and it also has space. All the leaves have space amongst each other so that they get equal amount of sunlight. Now, that is about the plant which has been adapted to wet environment. Similarly, the animals, the birds such as ducks and geese who swim in water, they have webbed feet, which is going to help them to swim easily. And suppose if we talk about seabirds, um, they have waterproof feathers because they are birds and they have to fly. If their feathers are not waterproof, they cannot fly with a wet feather. So that's why they've adapted to it, and they have waterproof feathers that they can easily come, catch their prey, and fly back again. Now, sea water is injurious to our health. We cannot consume water which has a lot of salt content in it, right? So these seabirds have a special gland that helps them to get rid of the salt when they are drinking the sea water. Again, we talk about flamingos. So flamingos have long legs, thin legs that helps them to walk through water easily. And they also have flexible necks so that they can look for their prey under the surface. Now, again, we talking about adaptation of plants and animals in cold environment. So before that, we need to know which plants grow in cold environment. The Christmas tree that we decorate, the fir tree grows in the winter, it grows in the cold climate. And how have they been adapted to it? So we know that the soil, if we read the last paragraph here, the soil in cold regions freezes in winter, right? And they have layers of snow over it. But in summer, definitely the snow is going to thaw. Thaw means it's going to melt and it's going to stay in water form. So if a tree is exposed to water for a longer time, what happens? It can erode, right? Mm, um, it can get damaged, right? So how the trees have adapted? They have um, a chemical that is known as resin on their bark, and it's a sticky substance which keeps the tree warm and also prevents them from losing their moisture. And resins is one of the adaptations that they have done. And secondly, the animals who stay in colder environment, they have thick fur, which is going to keep them warm. And also the other adaptation that we've learned is they migrate or they hibernate. So this is the adaptation of all the plants and animals. So you, even if they ask any animal that you're not familiar to, but these are the challenges that they're going to face, so you can use similar points in that answer also. Now it's 6.4. So before we go to 6.4, guys, I want you to pause here, take a break, read this whole chapter, that is 6.3. Make your notes also. I would love if you are making notes, underlining the key points, so that day before exam, all that you need to do is revise and just simply go through the notes. You don't need to read the entire sentences. These are the pointers, like large flat leaves, big airspace, Just revise it once and you will remember it for your exam. Orally answer these questions to test your understanding. Check your answer with the answer key that is provided by your school teacher. And yeah, that's it. Now, the last topic is adaptations of predators and prey. Now, what are predators and what are prey? In your previous grades, you have learned the food chain, right? Producer, consumers, you have predators, you have prey. So, your teachers exposed you to this vocabulary of predators and prey. Here, we are going to know how these predators and prey have adapted themselves to, use all the adaptations to the maximum benefit. Here, see that the leopard, the cheetah is a predator, and the prey is springbok. So, what are the adaptations? Cheetah is a fast runner. It has a streamlined body so that it gets less obstruction, and it has eyes. Both the eyes are in front so that it can see the prey and attack it. And also, the skin color of cheetah is camouflaging with the dry environment, as you can see. So this is blending, so the prey may not see the cheetah, and the cheetah may attack the prey. So these are the three adaptations that we've discussed for cheetah. Now, similarly, if the predator has certain adaptations, the prey also has it. So preys are generally weaker, right? But again, there are certain adaptations that they have done so as to escape from danger. Now, they prefer to stay in large group, and if some of them who can't run fast are the ones to be attacked by their preys. Now, if we talk about the points, we see the adaptations of predators. The stronger ones are the speed, streamlined body, camouflaging, even venom, that is poison. They can trap like how spiders trap. They have very good eyesight like eagle. They have good sense of smell. They have sharp, powerful teeth, sharp claws. They also work in a team, and they have good sense of hearing. So these are the things that you can work on. And you can answer the questions accordingly. Hmm. So here we are talking about two animals. We have snakes, and some snakes, especially cobra, they spit the venom rather than just biting and killing their prey. It spits venom on the prey, and then attack. It becomes very easy. So cobra spits its venom onto the prey to kill it, and yeah. And here we see falcon like eagle, and they have very good eyesight, and they can spot their prey when it is 3 kilometers away. It has a good eyesight, I would say. The claws that you see is quite powerful to catch hold of the prey. This is again an adaptation that it has done. The other adaptation would be the beak, to catch hold of the prey. Eyes are in front so that they can see clearly. Now, if we talk about the dogs that you see here, the hunting dogs, so they are definitely working in groups or pack. So that is the adaptation. They have a very good sense of smell, so they can know where the prey is. And the third thing that I can see visually is they can camouflage well with the environment. This is a crocodile, so it has sharp teeth. Crocodiles are very well camouflaged in the surroundings. And what else can you think of? Definitely eyes in the front so they can see clearly, right? Now, I have a confusion here. Is the eye in front or is it on the side? That is something that you have to think about and find the answer. So fish, they have their eyes on both the sides so that they can see if they are the prey or not. or the predator, they can see that is left and right. So that's again an adaptation. Now, we will discuss the adaptation of prey. Number one is defense. Defense means to protect themselves, they will prefer to hide. So even if they're out hunting, they are always restricted, restrained in areas where they have their hiding space or burrow. They're not going to leave that vicinity and go far away place, because if they inspect any danger, all that they have to do is hide in the burrow. They also tend to stay in a group so that they can send warning signals. There are animals who will make a certain noise and they're gonna saw sound and they're gonna warn the rest of the group. Bees use a smell as a signal, so that's how they're gonna give off a certain smell, and the other bees are going to smell it and they're gonna sense that it's the danger, and it's danger, and they're gonna just leave the place. um, Again, defense is protection. We know that tortoise and turtles, they are very, very slow movers. So how are they going to protect themselves? They're going to go under the shell, the hard shell, seeing sideways. Now, we see that many preys have eyes at the side of their heads, which helps them to see the predator on both the sides of them, that is left and right. And when I asked you that think about crocodiles, if the eyes are in front or on the side, I'm going to say that it's on the side, because crocodile resembles lizards so much. So if I'm saying that lizards have eyes on their sides, so does the crocodile. Fish also, they have the similar thing. Now, some animals can get away fast. If we talk about this octopus, it has a special gland which releases dye so as to confuse the predator. And by the time the predator realizes that it's not the prey will just move away. So that's how they do it. Attack. Porcupine, it's quite popular here. No animal would attack a porcupine, because if they dare to, they use their quills, um, to attack these predators, and that's how they protect themselves. So a porcupine spreads out and rattles its quill to make it look and sound more dangerous. If the predator still doesn't run away, they charge backward and stab the predator with its quill. The quill often break off, leaving the predator full of painful quills. So that's the end of this chapter, the entire chapter as well as the section. All that you would be doing now, children, is read 6.4 in depth, and you've already understood the process. When you're reading, make notes, try to do the question and answers here, and test your understanding. So that's all. I hope you got a thorough explanation of this chapter, that is adaptations of predator and prey. Very soon, I'm going to share another topic with you, which is on magnetism. And then that's going to give you a quick guide of how to prepare for another topic in physics, that is magnetism, force, and friction. I hope it was a wonderful learning to you. Let me know how did you find it in the comment section down below. Happy learning.